big heads up there. All right, so today we're going to talk about angles of elevation and depression. Okay, so we're looking at what these different angles are called, and then after we set up our problems, we're just solving for a side just like we were before using SOHCAHTOA. So we will still use SOHCAHTOA today. So I'm going to write that at the very top of your note sheet. So we don't forget what it is, since we will be using it today. Alright, so to make a field goal, a kicker must kick the football with enough force and at an appropriate angle of elevation to ensure that the ball will go through the goal post. This angle changes depending on the placement of the football from the goal post. Okay, so that different angle, it depends where you are on the field, but you have to kick it through a certain angle to make it through that crossbar in the goal post. So today, we will talk about horizontal distance and vertical distance. So just as a refresher, a horizontal line is left and right. Okay, horizontal is left to right. Vertical is up and down. Okay, so if I'm telling you that the horizontal distance from something is 20, then you know to label that horizontal line as 20. Alright, so our angle of elevation, that is the angle formed by a horizontal line and an observer's line of sight to an object above the horizontal line. Okay, so if I have this person here, okay, when we're talking about line of sight, there's always a horizontal coming off of their line of sight. Okay, so when you're looking straight forward, that's your horizontal. Okay, if they're looking up at something, okay, so looking up at something, that angle created by that horizontal and then their line of sight looking up is called their angle of elevation. So that would be right here in our picture. Okay, so that's your angle of elevation. You're looking up, so elevation. Okay, then we also have an angle of depression. That is the angle formed by a horizontal line and an observer's line of sight to an object below the horizontal line. Okay, so elevation was above, depression is below. So again, if I have this person, my observer, you always have a horizontal. Okay, so their normal line of sight. If I'm looking below that, so I'm looking down at something, okay, that angle formed right here, that would be your angle of depression. So it's always between that horizontal and then your line of sight. Okay, horizontal to line of sight. Okay, questions on those angles before I keep going? Alright, so horizontal lines are parallel. Okay, horizontal lines are parallel, meaning your angle of elevation will be equal to your angle of depression. Okay, they're going to be the same measure. So if I look at my picture to the left here, these are two people. Okay, your horizontal line here is the dashed line. Okay, those are parallel to each other. Now if the person down here is looking up at the person up here, okay, it creates that angle of elevation right here. And if this person above is looking down at the person below here, you have your angle of depression. Those two angles are equal to each other. Okay, those two angles created there are equal to each other. They're actually called alternate interior angles, and I know you kind of worked with that in middle school a little bit. So those alternate interior angles are equal. Okay, any questions before we get started? So today we are looking at some word problems, and we're just drawing a picture of what's going on. Okay, so I always want you to draw a sketch when you get a problem like this. Okay, since we are in a chapter with right triangles, you should create a right triangle somewhere in your sketch. Okay, that way we can use SOHCAHTOA. So example 1, Leah wants to see a castle in an amusement park. She sights the top of the castle at an angle of elevation of 38 degrees. So I know I have an angle of elevation of 38 degrees. She knows that the castle is 190 feet tall. Okay, the castle is 190 feet tall. If Leah is 5.5 feet tall, how far is she from the castle to the nearest foot? Okay, so we have to find how far away from the castle she is. So we want to draw a picture of what's happening. So I know I have a castle, right? Mine's going to look more like a tower. I'm sorry. If you want to draw a castle, you can. Here's my tower. Okay, this is my castle / tower. Okay, what do I know about that castle? What did I underline? What do I know about that castle? Anybody? It's 190 feet tall. Okay, so from the top to the bottom is 190 feet. Okay, so here's my castle. We also have Leah, who is standing further away from that castle, right? And we know Leah is 5.5 feet tall, so I want to label how tall she is as well. Okay, now this angle of elevation piece. We want to go from Leah's line of sight. Okay, so that's your horizontal. So her normal looking forward is that horizontal line. So that's this one right here. Okay, so here's my horizontal. Now she's sighting the top of the castle at an angle of elevation of 38 degrees. So I need to go from her eyes here to the top of the castle. Okay, so that angle I created between the horizontal and her line of sight is the angle of elevation, and I would label that 38 degrees. Okay, and we want to see how far she is from the castle. Okay, so we want to find that distance. So that distance would be her walking distance here. That would be that horizontal line. Okay, so that's what we're trying to find. So I'm just going to label it as X. Now, do you kind of see the right triangle I formed within my picture? Yes? Okay, so that would be this one right here. Right? Now notice, in my right triangle that I highlighted, it doesn't go all the way to the ground. Okay, it doesn't go all the way to the ground. So I need to find out what this length is from the top to this point where Leah's horizontal is. Right? How would I do that? John? Yes. So I would subtract Leah's height from that height of 190 to get that distance there. And that's 184.5. So now if this is too much for you to look at and you just want to look at a right triangle to use SOHCAHTOA to solve for that last side, I suggest you just redraw a right triangle below it. Doesn't have to be huge. Just redraw your right triangle and relabel it. Okay, so this is my right angle here. I know that vertical length is 184.5. I know this angle right here is 38 degrees. And then I'm trying to find that horizontal distance. Okay, so we've worked with problems like this before. Okay, it's a little bit easier to look at now. So this is where I'm going to use SOHCAHTOA. You need to go from your acute angle. Okay, so that's 38 degrees. From here we want to label our sides. Okay, I have a side across from that 38 degrees. That would be your opposite side. I have a side next to that 38 degrees. That's not the hypotenuse. So that would be adjacent. So I would be using tangent. Okay, I have O and A, so I'm using tangent. So we would take tangent of our angle, which is 38. Set that equal to your ratio of opposite over adjacent. So 184.5 over x. What do I do now? Multiply by whatever's in your denominator to both sides, because I want to cancel out that denominator on the right. Okay, so I have x times the tangent of 38 is equal to 184.5. I want x by itself, so divide both sides by tangent of 38. Okay, so we have x is equal to 184.5 over tangent 38. And you do want to be able to plug that into your calculator. Okay, you should have already had practice with that because you had a quiz on it on Friday. Okay, so I got 236.1. Now in my problem up here, it did say how far is she from the castle to the nearest foot. Okay, so to the nearest foot would be 236. Okay, so she is about 236 feet away. All right, questions? Why I labeled anything how I did, why I drew it how I did, where I got the angle of elevation from, anything like that. Okay, again, all of these problems, you should create a right triangle. Okay, so you should be looking for that right triangle in your picture. All right, then if we flip to the back, okay, I want you guys to do number 2. Okay, it's similar to what we just did. Talk to the person sitting next to you or people sitting next to you. Figure out how to draw that situation out. Before you get too far in solving, if I have a 5'6" tall acrobat, what is that in feet? It's 5.5. Okay, it's not 5.6. It is 5.5. 6 is half of 12. Okay. Actually be 5 and 6/12 because inches is in 12. Okay. So 0.5, just so you don't put 0.6. Once you've made your triangle, I want you to write an equation and solve then. I was trying to see what you're trying to find. Sorry. I was looking. Yeah. Yeah. I didn't know if you had to round to the foot, like a 10-year foot, or if you were rounding to like the 10. It's okay. Yes, you did. Yes. All right, here's my picture labeled. If you didn't get that far, use that to help you solve for that distance they're looking for. If you're done with this one and you want to try the next one, you can. It's a little bit different though. All right, so with my extra little triangle here, what would this vertical distance have to be? It would be 30.5. Okay, you have to add together your platform height, so 25, plus the height of the acrobat, which was 5.5. So it is 30.5 feet. Okay, from here, again, I can use SOHCAHTOA. So going from my acute angle of 27 degrees, if I look across, okay, that's the opposite side. The side right next to my angle is the adjacent side. So I have O and A again, so that would be tangent. So I have tangent of my angle, 27, is equal to the opposite side over the adjacent side. Okay, multiply both sides by x to get it out of that denominator. So we have x times the tangent of 27 is equal to 30.5. Divide both sides by tangent 27. Okay, I can plug this piece into my calculator then. And you should have had x is equal to 59.9. Okay, so we could say that audience member is about 59.9 or 60 feet away. How did we do on that second example? Working through it. We did okay? All right, any questions on that second example? How I drew it, where I got the side length from, where I got the angle from, anything like that? right, then our last example here, example 3. Those first two problems had to do with an angle of elevation. This one will have to do with an angle of depression. Okay, so a search and rescue team is airlifting people from the scene of a boating accident when they observe another person in need of help. If the angle of depression to this other person is 42 degrees, and the helicopter is 18 feet above the water, we want to find the horizontal distance from the rescuers to this person. Okay, so drawing a sketch here, we have a helicopter. I know. There's my helicopter. It's above the water. Okay, so I have some water here, helicopter, and I know there's a person still in the water. So I know this helicopter is 18 feet above the water. Okay, so it's 18 feet above the water. Now your angle of depression has to come from the horizontal and then looking down. Okay, so horizontal from the helicopter here. It's looking down at this person. Okay, so I have these two angles made. This is why angles of depression get a little bit tricky. So my angle is 42 degrees. Now your angle of depression has to be between the horizontal and the line of sight. Okay, horizontal and line of sight, not vertical and line of sight. Horizontal and line of sight. So my 42 degrees would be that top angle there. Okay, not the one between vertical and line of sight. From here, I need to find how far away the rescuers, so the people in the helicopter, from the person are. Okay, and that's the horizontal distance. So again, I'm looking for this horizontal distance here. Now this one is kind of hard to look at right now. But if I were to draw in a vertical right here, I kind of made a rectangle, right? What do you know about these two opposite sides here? They're the same, so this would be 18 feet as well. Same thing with these opposite sides. They're the same. Okay, so I'm going to use this right triangle right here. Okay, so I'm going to redraw that again. Okay, it's upside down this time. So here's my right angle. That vertical is 18 feet. I'm looking for the horizontal, and my angle is 42 degrees. Okay, so again, all I'm using is SOHCAHTOA. Go from your acute angle, so 42 degrees. Opposite that angle is 18. And adjacent to that angle is x. Now, when you do these problems, it's not always tangent. Okay, it's not always tangent. Don't get that in your brain. These ones just happen to be tangent. Okay, so I would use tangent of 42. Okay, that's equal to your ratio of opposite over adjacent. So 18 over x. From here, multiply by your denominator. So we have x times the tangent of 42 is equal to 18. And then we want x by itself, so divide by tangent of 42. And again, you can just plug that into your calculator right there. Okay, so 19.99 is what I got. So I can say that swimmer is about 20 feet away. How we feeling? How we feeling?